So we're going to be talking about trig graphs, and it's always good to do a bit of consolidation. And so I want you to look at these basic, these are the most basic or definitional trig graphs. We've got y equals sine x, y equals cos x, and y equals tan x. And I want to ask you to start with, what are some of the differences that you notice between the sine and cos graphs and the tan graph? So just take a moment to look at some of those basic bits of information. And what you can do is the things that you notice that are different, just put them in the chat. What do you notice that are different between the two basic types of graphs? Yeah. So if we talk about the period of the graph, so Fateko has said that the period is different, and we do notice that. So that is important. What else is, Kat has said the period is the same for the sine and cos graph. So you're absolutely correct. Anything else that's interesting or different? So the tan graph doesn't have an amplitude in the same way that a sine or cos graph does. And the reason is amplitude is how high or low you go from position of rest. So you can see you go one above or one below, and the same with the sine graph. But now with the tan graph, you can go up forever or you can go down forever. And so it doesn't make sense to have an amplitude like in the traditional sense. And so the A value in front of the tan graph, it just stands for the value that it gets to at 45 degrees. So you can still have like a number in front of the tan graph, but it just means basically affects how steep the graph is. So if you compare like the graph of, let me zoom in actually. So at the moment, this is the graph of y equals tan x. The graph of y equals 2 tan x would just look like that. And it would rise up steeper and be in line with 2 at 45 degrees. But in terms of being an amplitude in the traditional sense, it doesn't make sense because amplitude is how high or low you go, and the amplitude is sort of infinite in the case of the tan graph. Okay, the key features. Yep, I like what you, Irene, tell me more about, oh, here we go. You're talking about the tan graph. So the tan graph has asymptotes. So the tan graph has these asymptotes every 180 degrees, and these are lines that cannot be crossed. The other thing that comes into mind for me is with the sine graph, when I draw this, I normally draw it in quarters, like the first quarter, the second quarter, the third quarter, the fourth quarter. Whereas when I draw the tan graph, I normally draw it in halves, like the first half, the second half. And so that's just a kind of a physical characteristic. But when you draw the sine and cos graph, you tend to draw them in like quarters or of one period. Whereas with the tan graph, it tends to be in halves because they symmetrical kind of in half. Okay, that's just some kind of, give me a thumbs up if that all feels pretty familiar to you. Give me a thumbs down if you feel a bit like, whoa. Okay, now that is mainly grade 10 stuff. But when we get to grade 11, what we start to do is we start to talk about transforming the different types of basic trig functions. And what you notice is we have the A value in front. We have the Q value generally at the back. Oh, what happened there? Badly behaved. So let me try that again. So we have the yellow A value in front. We have the Q value over here. So let's just start with that. What does the yellow A value affect? What does the Q value affect? To give you an example, you could have something like y equals 2 sine x plus 1, or you could have, and that has changed the yellow value, and it's also changed the blue one, or you could, yeah. So what does the 2 do? What does the 1 do? I'll give you a bit of time to put in the chat or to raise your hand. So yellow changes the amplitude, and Q, what does Q do? So Q doesn't affect the amplitude. This +1 is actually what we call this Q is a vertical shift. So vertical shift. And so what this does is it moves the whole graph up by 1. Whereas the 2 over here, it stretches the whole graph up and down by 2. And we'll talk about that a little bit more later in the lesson. But if we imagine, maybe I'll do a little scribble just to explain. So if you think about a basic sine graph, it normally goes up, down, down, up. And the highest value it gets to is 1, and the lowest value it gets to is -1. If you change the amplitude to 2, then what's going to happen is the highest value it gets to is going to be 2. And the lowest value it gets to is going to be -2. And so the amplitude is kind of stretching the graph up and down, essentially. Okay, let me redraw this last bit. Okay, now, so that's what the yellow bit does. What does the +1 do? The +1 simply moves the whole graph up by 1 unit. So if you have a +1 at the end, all that's going to happen is that instead of starting here, the graph is going to start here, and it's going to go up by 1, and then it's going to go down by 1, and then down by 1, and then up by 1. So there's a difference between shifting up and changing the amplitude. Give me a thumbs up if you understand what A and Q do. Okay. All right. Now let's talk about the K. What does the K value seem to do? And there's some different formulas here. There's a formula that involves the period and K on this side, and then there's another formula over here. And I'm wondering how we can connect these. So Impor has said that the K value affects the period of the graph, but why are the formulas different? Why is the one formula involving K with 360 divided by K and the other one 180 divided by K? Who could tell me that? That's the period. Yes, cat of what? Aha, yes. So here we go. Impor and Bongakosi, you're on the right track. This one is for the tan graph because the tan graph has a period of 180. And this one is for the sine and cos graph. And what this does is the K value or the pink value changes the period. And this tells us how. So if I had an example of this would be if I had y equals sine 2x. This 2 is the value in front of the x, and it will take the period of the sine graph, which is normally 360, and I divide it by the 2, and the new period will be 180. And so we've halved the period if the K value was 2. If the K value was 3, then you would divide it by 3. Okay, so that's what that K value does. Then the last one, before we start playing with some examples, what does the plus P do in all these trig functions? And what does the plus P do? Okay, yep, it's the horizontal shift. And you can kind of feel this if you think about what we were doing with the algebraic functions. And remember that the horizontal shift is a bit special. It always moves the opposite way. Okay, so if it's a plus, it moves to the left. If it's a minus, it moves to the right. But basically, this is just a horizontal shift. If it was by itself, the graph of sine x plus 30 would be a horizontal shift, and it would move the whole graph 30 degrees to the left. And that value over there is the P value. Okay, so we've looked at the basics of trig graphs. We've looked at the basic characteristics. And now we've looked at the grade 11 transformations. And what we need to be able to do is get more comfortable with these interpretation of these transformations. Give me a thumbs up if you've broadly followed the ideas that I've explained. And then if I've seen that, I can move on to some basic questions. Okay, Owande, Ongani, Kosi. Okay. Let us go to some multiple choice questions about these basic ideas we've been talking about. So question number 1, the graph of y equals tan theta in the domain 0 to 360 is not defined when theta is what? It's not defined when theta is what? And you need to tell me, do you think it's A, B, C, D, or E? And I'll ask you to consider, what does the normal tan graph look like? When you think about the tan graph, when is it undefined? What does it mean to be undefined? So the normal tan graph in 0 to 360 would have an asymptote at 90 and again at 270. And those asymptotes are where it's undefined. So you can imagine it looks kind of like that, and then like that. So the correct answer is going to be 90 and 270, or D. Okay. So when we say undefined, we're looking for the asymptotes. And if you use your calculator, you can also see on those tables, you kind of see like question marks or undefined. Okay, let's do another one a bit like that. This time, it's asking, what is the period of the trig graph y equals sine a half x? Which of these 5 options? And while you do that, I'm going to go grab a light so that I can plug it in. So these options do we think is right? So the formula that we saw in the earlier thing for sine was to go 360 divided by k to get the new period, because the old period was 360. Now this value is going to be 360 divided by a half because of this thing. So then 360 divided by a half is actually going to be 720 degrees, which is going to be C. So watch out for that, because when you divide by a fraction, you actually get a bigger number. So it's increased the period. If you wanted to visualize this graph, each of the quarters, instead of going in 90s, it's going to go in 180s. And so for a whole sine graph, you're going to need 720 degrees of runway. So you would need to go up, down, down, up. That's just a bonus drawing. I see quite a few, there was some good debate going on there, so we probably learned quite a lot. So remember that for the formula for determining the new period is the old period divided by the number in front gives you the new period. Okay. Let's do another one. You are given a cos graph that has two types of transformations, but they still want to know what is the period of this cos graph. And you've got 5 options here. What do we think it's going to be? So they're trying to distract you a little bit because there's a 2 in front, but that's not what you want to worry about. You want to worry about that 3. And so what we see is to get the new period, we go 360 divided by 3, which is 120, and that should be E. Just out of curiosity, what is the 2 over here doing to the graph? So the 3 is changing the period. What is the 2 doing to the graph for bonus points? What does that do? Yeah, it changes the amplitude, or it stretches the graph vertically. So if this started out in life as a normal cos graph, it would only go between 1 and -1, but because of that 2, it's going to go between 2 and -2. And then, yeah, so that is good. And I think you all get that, so that's fine. Okay, I'm liking what I'm seeing in terms of interpretation. Let's try another multiple choice. Which graph is represented below? So now we're going the other way around. I give you a graph and you need to match which of these matches with which trig graph equation. Let's see what you can do. So what type of graph do we think this is? Okay, so it looks to me like the period of this graph is 120. You can see it goes down, down, up, up. I also think it's a cos graph because of the shape. You can see it goes down, down, up, up. But it's not y equals cos x because the period has been changed. Now, the only one that is a cos graph and that's had the period changed is going to be B. And the period of B would just be 360 divided by 3, which matches this. Yeah, we're gobbling this up. Fantastic. Let's keep going. Well, let me just do a quick little check. Thumbs up if we feel like you're following and things are going okay. Thumbs down if you feel like we're going a little bit too fast for you, or maybe I'm losing you. Okay. Cool. Remember, always be honest, because I don't always have your visual faces to see, but I need to sort of read the feedback from the class in the chat to help guide me. Okay. Let's do this one. You're given a graph. In fact, before we do this, I want you to tell me what are the 2, before we even answer the question, what are the 2 changes that are involved in this particular sine graph? There's 2 types of changes. I want you to tell me what is happening before we answer the question. Put it in the chat or... Okay, so the green one you've correctly identified the horizontal shift. So this is the plus P value. It's a horizontal shift. The 2 over here, that is like the K value. So that's like the P value. So this is period change. And so the K is the period change, and the horizontal shift is the value over here of the P. Okay, now, well done. It's not amplitude. Hey? Be careful. Amplitude would be the number in front. That would be amplitude. So if there was a number in front of all these, that would be amplitude. And if there was a number hanging out the end, that would be like a vertical shift. But these two values, the plus 30 is the horizontal shift. The 2 is going to be the period change. Now, you have to find the period of this graph and match it to another graph here that has the same period. And so I want to see if you can do that. So I suppose we should work out the period of this graph first. And the period of this graph is going to be 180. Now, it would be helpful to know the period of these graphs. So that would be which of these 5 has the same period as the original? It has to be A, yeah. So the normal tan graph has a period of 180 degrees. Cool, yeah, that wasn't so bad. So again, we call this graphic interpretation because we're interpreting these trig graphs and we're understanding the various types of values that can be changed and what they mean. And I'm happy with what I'm seeing so far. So do we always use this method? Or there are other ways of doing it, but I think basically, you can visually look at the graph and see how long it takes to repeat a cycle, and that will tell you the period. Or you can use that formula that we've shown where you take the normal period, divide by K, and then get the new period. So you do have a choice, but this way is most students seem to gravitate towards this. Okay, does that answer your question, I wonder? Then, can you do this question? This is about the range of this. This is a sine graph, but it's had something interesting happen. So I wonder what that 1 does. Maybe someone can help me in the chat to offer some suggestion about what the 1 does, and then I'll give you some time for the answer. Yes, Nompilo, yes, it is a vertical shift by 1. So now you need to ask yourself, what is the range of this trig graph? So import, that's a good question. So the number in front of the, okay, so it's kind of one of those words where it's not that, yeah, we would just call it the number in front of the tan. And it's not officially the amplitude because, well, the amplitude, another way I've heard it said is the amplitude of the tan graph is infinite. So it can't be the number in front. So it's just the number in front of the tan. Yeah. Be careful with this question, because if you are a normal sine graph, let's have a look. How do you behave if you're a normal sine graph? You go up, down, down, up. And you are between 1 and -1. If you are a special sine graph and you get moved up by 1, you are then going to start here and go up by 1. Then you're going to go down by 1, down by 1, up by 1. And so the range in which you exist is going to be a bit different, because it looks to me like you get as high as 2 and as low as 0. Yeah. So now which of these 5 options describes this range over here between 0 and 2? I think it's not going to be this one, not going to be that, not going to be that, not going to be that. It's going to be this one. It's going to be C. Yes, Gebotso. That is correct. So that was a bit harder. And what this shows you is that the range has just been shifted. Everything, the normal sine graph has a range from -1 to 1. But if everything shifts up by 1, well, what's -1 plus 1? It's 0. What's 1 plus 1? It's 2. And so that's why the range is now between 0 and 2. If I changed the amplitude, it would have been stretched up or down. But for now, that was just a shift up. All right, everyone, it's time for a break. I have not managed to get my light turning, so we are just going to have to kind of do this with me in the dark somewhat, although maybe you'll see me from a distance. So let's turn. I don't know if you can be able to see me now, but let's see. Oh my gosh, I look like I'm camping. Okay, let's go back to I'll go back to this. All right, everyone, you know the drill. Stand up on your feet. I'm going to try and make sure you can see me, but I'll audibly give instructions if you can't. So let's just start by standing up and stretch your arms up. And I want you to pretend you're trying to touch the roof. And I want you to use your eyes and look off into the distance. So look off into the distance, give your eyes a break. Instead of focusing in front of you, let them focus far in the distance and keep your arms up nice and tall so you're stretching. And then bring your arms down and just shake them out. So shake out your arms. Just get that body moving. Then shake out your legs. So I'm feeling nice and loose. Let's roll the shoulders back 5 times. 1, 2, 3, 4. Roll the shoulders forward 5 times. Okay, and shake out the arms again. And let's do a bit of a rotation. So your arms out horizontally, and you're going to turn your body a little bit. And then to the other side. And each time you rotate, you're going to feel your body going a little bit further. And hopefully, as you relax, you should feel yourself going further. Okay, and then shake it out again. Then let us do a shoulder stretch, so like a tricep. So like this. Because I know we hunch over when we're sitting at our desks. And then the opposite shoulder. Oh, that feels good. And then just shake it out. All right, let's do some cardio. Let's just do 15 jumping jacks. Make sure that the space around you is clear, that you don't whack anyone. And we're going to go in 3, 2, 1. Let's go. 3, 5, 6, 7, 8, 10, 12, 13, 14, 15, and stop. Okay. My body feels like it's had a bit of a break, and I hope yours does too. And while we wait to settle into part 2 of the lesson, tell me what a giraffe is worth. No, let me put my camera down here. Monkeys and giraffes, something a little different. So we know the monkey has to be 4. But now we have to work out what this giraffe is doing over here. So we have the power of equations. And using the power of equations, that 2 can become a times 2 on that side. Because if we do the same thing to an equation, whether it's a monkey or a giraffe equation, it's still an equation. So 4 times 2 is 8, times 2 is 16. So I've got a giraffe, not a very, excuse my giraffe, but my giraffe plus 3 is equal to 16. So what is the giraffe going to be? It has to be 13. Yes, Nompilo, I agree. Paul, same thing. Daniel,
Nicely done, everyone.
Okay. Yes, well done. Can't we just cancel out the 2 we were given? Aha. So Andile, the problem is that the 2 that is over here is a division. And what undoes divide by 2? So you would actually have to times both sides by 2, and then the 2's could cancel out. But then you still have to have this 2 over here interacting with this 2, which gives you 4. And then the monkey was 4 from above. So you have 4 times 4, which gives you the 16. Okay. All right. So that was just a little bit of fun from our brain puzzles. Let's get back to our lesson. Okay, so where were we? I know I'm doing lots of multiple choice questions, but I think it's a really great way to just build your confidence with interpreting trig graphs. So in this question, you're given a trig graph that does something. You then need to connect it to another trig graph called G and identify which of these 5 options is the right one for G. And I'm not going to say too much more than that. I want you to read this and think about it. I'll give you some time, and then we can have a discussion or ask some questions. Ask yourself, what does that do? And what does this do? So ask yourself, remember that the f function, the function f is the one that's down here. And that function f, they give you the formula. But what they want is they want the equation for the function g. That's the question you need to think about. What is the relationship between f and g, and how can you use that to figure out the equation of g? I like that this is pushing you guys. So for me, the relationship between G and F is that to get from F to G, I just have to add 1. I mean, it looks to me like they're always 1 apart, which means all I need to do is say, what is the F function? The F function is the sine of X minus a half. But to turn it into the function G, I need to add 1 on the end. But then the question becomes, what can't I simplify that? And so we would get that the g of x is equal to sine of x plus a half, because minus a half plus 1 is plus a half. Now, is there a G that matches that? It looks to me like it would be D over here. Now, I see, take a moment and think about if you followed my explanation. So to get from F to G, I had to add 1. Sorry, to get to G from F, I had to add 1. See if you agree. If you do agree with my answer of D, give me a thumbs up. If I've lost you in that explanation, give me a thumbs down. Okay, so the reason this was harder is that minus half is actually just a Q value. It looks very sneaky, but all that does is shift the original graph down by a half. That's why, can you see the yellow one is just going down by a half? And then what is the relationship? This is just 1 above that. And that's why it goes from minus 0.5 up like that. So Andile, all I did was I said that the original function f is f of x equals sine x minus a half. So that's this one over here. But to get to the green one, what I need to do is I need to raise it up by 1 or add 1. So I add 1. But now this bit over here can be condensed into minus a half plus 1 can just become plus half. Okay, cool. Now, another part of trig graphs is solving trig equations. And so it's quite important that you have a good understanding of how to solve trig equations quite quickly. And I also want to connect trig equations to intersection points. So say, for example, I say to you, sine of x equals 0.2. Solve this trig equation in the domain 0 to 360. That's what this first question over here says. Well, then we're looking for a value of x such that when I take the sine of that x, I get 0.2. So that's the one way of thinking about it. But another way of thinking about it is that I'm finding, to solve this equation, I'm finding the intersection point of two graphs called, one is y equals sine x, the other one is y equals 0.2. And if I take these two functions and I make them equal to each other, I will find the intersection points. Because whenever we want to find intersection points between two functions, we just make them equal to each other. So take a moment and give me a thumbs up if you understand that solving this equation is the same as finding the intersection points between the graph y equals sine x and the graph y equals 0.2. So on one level, I'm looking for a value of x that makes the sine of x 0.2, but on another level, I'm trying to find the intersection point between y equals sine x and y equals 0.2. So it's the same thing. We're trying to solve this trig equation. So now, if I want to see the solution to this visually, I need a sine graph. So let's do this. Let me use blue, and the sine graph goes up, down, down, up. And the highest value it gets to is 1. The lowest value it gets to is -1. Then, if I want to visualize the graph of y equals 0.2, it could look, oh, let me undo that. It could look something like this, where this value is just 0.2. This is a constant function. Now, if we think about how our trig graphs work, I'll put the going from 0 to 360. Now, what this is telling me is that the answer to my equation, there's one answer over here, there's another answer over here. And so what we see from this graphical representation, there isn't just one solution in 0 to 360, there's actually two solutions. Give me a thumbs up if you follow the idea that there are two solutions here. Oh, Andile, you're on the right track there. Okay, now, in the next part, we have to figure out what each of these solutions are. And the way we do this is we decide in which quadrants we're dealing with, and we also deal with something called a reference angle. And so to solve this question, I want to first, step one, is I want to say, what is my reference angle? And the way I get my reference angle is I take the sine, shift sine 0.2, and what do I get? So I go in my calculator, I go sine of -1, so I go sine -1 of 0.2. And what value am I going to get? We call that the reference angle. Okay. And that reference, what you should get for that reference angle is you should get 11.54 degrees. Give me a thumbs up if you get that for your reference angle. Okay, now, for a trig equation, one of the problems we have is that you've only got one of the answers. You've got the very first one, 11.54, which is this one over here. But how do we find the second answer to this? And the way we do it is we use something called the cast diagram. And we can even look at the graph here and say, in which quadrants is sine positive? Where is sine positive? You can see on the graph, it's positive between 0 and 180. Another way of saying that is saying that the answer to this equation will be in quadrant 1 and quadrant 2. Now, this is where you might have to go back and look at some of my older lessons on trig equations, but we say that the solutions in quadrant 1 will always be the reference angle, let's say x, and the solutions in quadrant 2 will be 180 minus the reference angle. So, how do I get the answer for this? Well, the very first answer is in quadrant 1, and it's going to be theta, not x. Sorry, I should have used theta there. Oh, no, it is x. Sorry, yeah. So I'm going to say x is equal to 11.54, but the solution in quadrant 2 is going to be 180 minus 11.54. Can somebody use their calculator to give me an answer for that one? We get 168.46. Now, if I've told you the truth, the whole truth, when you type in your calculator the sine of 11.54 or the sine of 168.46, so let's put that, I should get the value 0.2. If I don't get close to 0.2, this method doesn't work. So can you please all put in your calculator the sine of 11.54 and the sine of 168.46. And if you would get 0.2, or if you get close to 0.2, give me a thumbs up. If you're getting something different and you're not getting an answer to the equation, give me a thumbs down. Okay. It seems like we're on the right track broadly. So what I want to suggest, and we're going to carry on with this in the next lesson, is in order to interpret graphs, you do need to be able to solve trig equations. And so if I'm going to go over this 3-step process now with you, but I've done whole lessons on how to solve a trig equation in the earlier trig module, I just want to give you the little overview quickly. So step 1, when you have a trig equation, you're always going to have something that's unknown like x, and you need to find the value of x that makes this thing true. So in this case, what value of x will make the sine of that x 0.2. You find your reference angle. When you find your reference angle, and we're going to talk about this in the next lesson, you don't actually include negatives if there are any. Now, in this case, there wasn't a negative involved, so it was fine. I just go shift sine 0.2, and I got my reference angle. And then I ask myself, in which quadrants is sine positive? It's positive in quadrant 1 and 2. What form do angles take on in quadrant 1 and 2? Well, that's x in quadrant 1, 180 minus x in quadrant 2. And so that should have been reference angle. So you go, the first answer is just the reference angle. The second one is 180 minus the reference angle. And so then you've got your two answers. And what's more, these answers repeat themselves every 360 degrees. Okay, so that is my little summary. It was a bit of a recap of a previous lesson. And if you're unsure, I really recommend you go and look at a previous video about trig equations before our next lesson. Okay, because you do need to be able to do this quite easily. Okay, are there any questions or comments from the class? Or anything you want to know a bit more about in terms of solving? Should we do one more? Let's try and do, to end today, let's do B. Let's try and solve the trig equation for the cos of x equals minus 0.3. So I'll draw it here. The cos of x equals minus 0.3. But what I want you to remember is that when you calculate the reference angle, you need to ignore that negative. So off we go. And for those who are feeling stuck, please raise a hand or let me know. For the rest of us, I want to solve this trig equation in the domain 0 to 360. And I'll even give you a little cos graph to help you. You can do it. So it feels to me like the answers are going to be sitting somewhere over there. So step one, what is the reference angle? I go second function cos, but I don't use negative 0.3. I just use 0.3. Can someone give me my reference angle? So the reference angle is 72.54. But if we look at my drawing, can you see how 72.54 cannot be an answer to my equation? If I try the cos of 72.54, I will not get 0.3. And that's because of the second step. If we look at the second step, in what quadrants is cos negative? Cos is negative, or you can see it on the drawing, it's negative between quadrant 2 and in quadrant 3. And you can see this visually if you look at the graph between 90 and 270, that's where the graph is below the line. Now, to find the answer now, all I need to do is go 180 minus the reference angle to get the answer for quadrant 2, and 180 plus the reference angle for quadrant 3. So what is my answer going to be? Well, x is going to be 180 minus 72.54, or x is going to be 180 plus 72.54, which gives me 107.45, or what is the other one going to be? 252.54. And just to make sure I'm telling you the whole truth, I want you to put in your calculators the cos of 107.45 and see that you indeed do get negative 0.3 approximately. And just give me a thumbs up if when you plug it back in, you see that the answer is telling the truth. Okay. Now, what's different about tonight is I really want to focus on, in previous modules, we've learned how to figure out the answer to a trig equation. And what I just want to emphasize a little bit more today is how, if we look at the graph, if we look at where cos x meets the graph of minus 0.3, the one answer is 107.45, which is the one that you worked out over here. And the other answer over here is the 252.54. And I just want to make the connection between the graph and the algebra for you. Okay, so that was, and then on Wednesday, we will continue with this idea of interpreting trig graphs and using methods to figure out questions related to trig graphs.